Hi, I'm Hamza. Welcome back to the Orchesty tutorial series. So in this video, I'll show you how to work with the limiter. The limiter controls requests sent to external APIs to prevent exceeding their rate limits or overloading the target service. Orchesty uses the limiter to control the request rate to a given API across all topologies and their connectors. If you'd like to try the example yourself, you can find instructions on how to download and set up the demo worker in the link below. Let's get started. For this tutorial, we'll import the sample topology called demo limiter. Once again, you can find it in the topologies folder of our demo worker. We can now see the imported topology, so let's briefly go through its elements. The first one is a cron trigger, which we already know. If you watched the previous tutorial, you'll also recognize the following batch node. It gradually retrieves 10 pages, containing 10 products each, and sends all 100 messages to the topology queue. The next element is a mapper, which extracts the ID from the retrieved data. The final element can then use this ID. It is the connector we already know, which retrieves the details of a specific product based on its ID. As a whole, this topology now resembles a real-world pattern that appears very frequently in integrations. Before we begin, we'll add breakpoints to the topology. We're going to demonstrate the limiter, which applies a shared request limit across all connectors belonging to the same application. To increase the load on our mock server API, we'll create a branch and use the connector a second time. By default, when a topology branches, Orchesty sends a copy of each message to every branch. We'll cover routing in more detail in a separate video. We'll save the topology now, but before publishing it, let's make a quick detour. Some of you may have trouble publishing another topology because trial instances have a limited number of slots. In Orchesty, a slot represents one published topology. Essentially, it is the number of running orchestration services. You can easily free up a slot by unpublishing one of your previous topologies. There's no need to delete it. Simply unpublish it and its slot becomes available again. Now, let's return to our example. We'll publish and activate the topology, but before starting the process, we still need to configure the limiter. This is done in the application detail. Go to the applications overview and open our product test application. In the application detail, open the limiter tab, where you'll find a simple configuration. We'll set the limiter to 2 messages per second, save the settings, and then return to the topology. Start the topology. We can immediately see at the individual nodes where the limiting takes effect. When we click an element displaying the limiter icon, the toolbar above the canvas shows the current number of messages being held by the limiter. The first batch node still shows only one message because it received a single input message and processes the pages one by one. The connectors behave differently. Here, we can see the number of messages fluctuating depending on how quickly the limited messages are processed and how quickly new messages arrive. The breakpoints then show how many messages have been processed in each branch. As you can see, the mapper is not affected because the limiter is only applied to connectors and batch nodes. That's how easy it is to handle rate limits with Orchesty. The limiter can also be configured in code with multiple levels of limiting, which is especially useful for multi-tenant integrations. Let's also take a look at the limiter overview. Here we can see the limiter metrics and its current status. This view is particularly useful when transferring large amounts of data to a service with a low rate limit. You can monitor whether the processes are handling incoming messages quickly enough and whether too many messages are accumulating in the limiter. Rows aggregated by application also show the approximate time required to process the limiter's current backlog. In critical situations, you can terminate the running processes. That's all for this tutorial. I look forward to seeing you in the next video.